I'm Ryan Pack,
And I'm Ryan Bounds.
and this is our tutorial on cross sections and revolutions. For revolutions, there are two base formulas called dish and washer. For dish, there cannot be a hole between the line and the axis of rotation. For washer, if there is a hole, then you use the original line and the line of the hole and subtract them around the axis of rotation. For this line, you need to use the dish method. Since there is no hole between the line and the axis of rotation, you need to input the equation of the line with the bounds into the dish formula. So right here you see the exponent and the square root cancel out, making it just x. Then you find the integral of that, which gives you x squared over 2, and use the equation f of b minus f of a, and you plug in 4 for f of b to get 16 pi over 2, and 0 for f of a, which cancel out, making it just 0, giving your final answer, making it 8 pi.
Here we use the dish method, but this time we're going to rotate around the y-axis, so we have to convert the equation of the line into terms of x, and then input that into the formula for dish method. So our square root of x is going to become the positive y squared. We're going to go ahead and input that into the dish formula. We're going to simplify by distributing the exponent, so giving us y to the 4th power. I'm going to take the integral of that, giving us y to the 5th power over 5, evaluated from 0 to 2. We're going to use f of b minus f of a, which is going to allow us to find our final answer after simplifying, and our final answer is going to be 32 pi over 5. Here you have to use the washer method, as there's a hole between the area that you are rotating and the line of rotation, which in this case is the x-axis. You have to take the equation of the line on top of the area you're rotating and plug it into the big Rx side of the washer equation, and then take the line that is on the bottom of the area you're rotating and plug that into the little Rx side of the washer equation. So you'll be doing the integral of the top line minus the integral of the bottom line. And next we'll just be simplifying. So we can simplify the two integrals together to give us the pi times the integral from 0 to 1 of x squared minus x squared to the 2nd power. And then again, we're going to continue to simplify, giving us x squared minus x to the 4th. And then we're going to take the integral of that, and we're going to get x to the 3rd power over 3 minus x to the 5th power over 5, evaluated from 0 to 1. And then we're going to plug in 1 into that equation there, giving us 1/3 minus 1/5. And we're going to skip the 0 part because that will just cancel out on its own, because 0 over 3 and 0 over 5 are both going to be 0. We're going to find the common denominator and subtract 5/15 minus 3/15, and we're going to get 2 pi over 15. Now we have another washer method, but this time we are rotating around the y-axis. So we have to convert both equations of the lines into terms of x instead of terms of y. So our x squared is going to become the square root of y, and our x is just going to become y. And that's going to give us the equations we're going to be putting into the washer method. And we're basically going to be following the same steps from the previous example, except this time we're going to be putting the right side of the area being rotated as the big X and the left side as the little Rx. So we'll be doing the integral of the right line minus the integral of the left line. And now we're just going to continue to simplify, and we're going to put the two together, giving us pi times the integral from 0 to 1, the square root of y squared minus y squared. And we're going to simplify again. We're going to do the integral from 0 to 1 of y minus y squared, and then we're going to take the integral of that, giving us y squared over 2 minus y to the 3rd power over 3, evaluated from 0 to 1. We're going to plug the 1 into the equation, giving us 1/2 minus 1/3, again skipping the 0 because 0 over 2 and 0 over 3 are both 0, so they don't matter to the equation. We're going to find the common denominator and simplify all the way, giving us our answer, pi over 6.
So now we are starting with cross sections. This question wants the cross section with a square between f of x and the x-axis. Cross sections use the base equation of the integral from a to b of a to x dx and a of x is the area of the object in the cross section. So on this, a of x is going to be base times height, since the area of a square is base times height. So x to the fourth is going to be the area of the square. So using the bounds 0 to 2, we're going to find the integral of x to the fourth, which is x to the fifth over 5. And then we're going to evaluate using the f of b minus f of a equation, making it 2 to the fifth over 5 minus 0 to the fifth over 5. The 0 cancels out, giving you 32 over 5. This question asks for the cross-section with an isosceles triangle with its hypotenuse on the base of the cross-section. You can use this equation of the integral of 1/2 times big Y minus little y times big Y minus little y over 2 as your a of x, since it's simplified version of 1/2 times base times height for this situation. Plug in x squared for your big Y and 0 for your little y, giving you this following equation. So then you simplify, giving you x to the fourth over 2. Then you find the integral, giving you x to the fifth over 10. Simplifying it, giving you x to the fifth over 20. Then you use the equation f of b minus f of a to give you 2 to the fifth over 20 minus 0 to the fifth over 20. Canceling that out, giving you 32 over 20, simplifying, giving you 8 over 5.
This question asks for the cross-section with a half circle on the base. You'll use the 1/2 times pi times r squared for your a of x, since that is the equation for the area of a half circle. Then you're going to go in, plug x squared over 2, because x squared is going to be your diameter and you need the radius. So you're going to plug x squared over 2 in for your radius. And you can take 1/2 pi out to the outside. So you have pi over 2 times the integral from 0 to 2 of x to the fourth over 4. Because you go ahead and distribute the exponent inside. Take the integral of that, giving you x to the fifth over 20, and you have to multiply that by pi times 2, and then you're going to evaluate it using f of b minus f of a, and you're going to get 2 to the fifth power times pi over 40. You're going to continue to simplify, 32 pi over 40, and then your final answer after simplifying again is going to be 4 pi over 5. For this question, we have an equilateral triangle as the base of the cross section, so you can use the integral from 0 to 1 of the square root of 3 over 4 times big Y minus little y squared as your a of x, since it's the simplified version of the area of the equilateral triangle in this situation. You're going to go ahead and plug x in for your big Y, because it's the line that is on top of the area that is going to have the cross section in it, and x squared as your little y, as it's the line that's on the bottom of the area that's going to have the cross section in it. You can go ahead and move the square root of 3 over 4 to the outside, and then you're going to have to FOIL the x minus x squared times x minus x squared, giving you x to the fourth minus 2x to the third plus x squared. And then you go ahead and take the integral of that, giving you the square root of 3 over 4 times x to the fifth over 5 minus 2x to the fourth over 4 plus x to the third over 3, evaluated from 0 to 1. And then we're going to use our f of b minus f of a and input the 1 into the equation, giving us 1/5 minus 1/2 plus 1/3. And of course the zeros cancel out, so we're going to be leaving that alone. After finding the least common denominator and then multiplying their solution together with the square root of 3 over 4, you're going to get the square root of 3 over 120 as your final answer.
This one has the isosceles triangle with one of the legs as the base of the cross section, and you can use the equation of the integral from a to b of 1/2 times big Y minus little y times big Y minus little y as your a of x, since it's the simplified version of the area of the triangle in this situation. So you plug in x squared as your big Y and 0 as your little y, simplifying it into x to the fourth dx. Then you find the integral of that, giving you x to the fifth over 5 with the bounds 0 to 2. You then simplify using f of b minus f of a, giving you 2 to the 5th over 5 times 1/2, and the zeros cancel out. So you simplify that, giving you 32 over 10, simplifying to 16 over 5.